cosm. Whoosh.
Look up at the night sky. Those pinpricks of light, scattered across the cosmic canvas like diamonds on velvet, represent billions upon billions of stars. Around each one, statistically speaking, orbit worlds. Rocky planets. Gas giants. Moons bathed in subsurface oceans. The mathematics alone suggests that somewhere out there, life has taken hold. Intelligence has emerged. Civilizations have risen. And yet, we hear nothing. No radio signals. No megastructures blocking distant starlight. No interstellar armadas crossing the void. Just silence. Profound, unsettling silence. This is the Fermi paradox, named after physicist Enrico Fermi, who asked the simple yet devastating question, where is everybody? If the universe is so vast, so old, so filled with potential cradles for life, why haven't we encountered anyone? Why does it seem like we're alone in a cosmic mansion with 10,000 empty rooms? The answers we've proposed range from hopeful to horrifying. Perhaps intelligent life is simply rare. Perhaps civilizations inevitably destroy themselves. Perhaps the distances are just too vast, the time scales too long. But there's another explanation, one that sends chills down the spine of anyone who truly contemplates its implications. An explanation that suggests we should stop broadcasting our existence into the void immediately. It's called the dark forest theory. And if it's correct, humanity may have already made a fatal mistake. The theory takes its name from a science fiction novel by Chinese author Liu Cixin, but the concept itself is rooted in game theory, evolutionary biology, and the cold mathematics of survival. Imagine the universe as a dark forest at night. Every civilization is a hunter, moving silently between the trees, because the forest is full of other hunters. If you reveal your position, if you make noise, if you light a fire, you become visible. And in this forest, visibility equals death. Why? Because of a chain of logical assumptions that, once you start following them, become almost impossible to refute. First, assume that survival is the primary need of any civilization. This isn't cynicism. It's basic evolutionary logic. Any species that doesn't prioritize survival doesn't last long enough to become a civilization. Second, assume that resources are limited. This is fundamental physics. The universe contains finite matter and energy in any given region. Third, assume that civilizations can never be certain of other civilizations' true intentions. Even with communication, motives can be hidden, strategies can be deceptive. Now, add one more factor, the cosmic time lag. When we look at a star 1,000 light-years away, we're seeing it as it was 1,000 years ago. If a civilization exists there, they could be exactly where we are technologically, or they could have progressed to godlike capabilities in the centuries since that light left their world. By the time we detect them, by the time we send a message, by the time we receive a reply, hundreds or thousands of years might pass. Civilizations could rise and fall in that interval. Technologies could advance beyond recognition. In this environment, what is the safest strategy for a civilization that detects another? The dark forest theory provides a brutal answer: strike first. Strike immediately. Strike without warning or mercy. Because waiting means the other civilization might develop superior technology. Attempting communication means revealing your exact location and capabilities. Doing nothing means accepting an unknown threat on your cosmic doorstep. The only guaranteed safety is elimination. This creates what game theorists call a defection cascade. Even if most civilizations are peaceful, it only takes one aggressive species to change the equation. If there's even a tiny chance that the civilization you've detected is hostile, or might become hostile, or might decide you're a threat, the logical move is to destroy them before they destroy you. And since every civilization knows every other civilization is doing this same calculation, everyone has an incentive to shoot first. The forest stays dark because anyone who lights a fire gets extinguished. Now, consider what humanity has been doing for the past century. We've been screaming into that dark forest with every radio and television broadcast, every radar pulse, every deliberate message sent to nearby star systems. The Arecibo message, transmitted in 1974 toward the globular cluster M13, contained information about Earth's location, human DNA, and our atomic structure. The Voyager probes, now in interstellar space, carry golden records with Earth's exact position mapped against nearby pulsars, along with sounds and images of our civilization. We've essentially stood up in the dark forest, lit a bonfire, and started shouting our coordinates. The optimists among us have always assumed that any civilization capable of interstellar travel would be peaceful, enlightened, beyond the petty conflicts that plague our species. After all, they would argue, a civilization that managed to avoid destroying itself must have evolved beyond violence. But this assumption reveals a dangerous anthropocentrism. It projects human values, human psychology, human developmental patterns onto entities that might be fundamentally alien in every conceivable way. Consider the intelligence on our own planet. Dolphins are intelligent, even self-aware, yet they engage in what can only be described as warfare, including infanticide. Chimpanzees, our closest relatives, conduct coordinated raids on neighboring troops, brutally killing rivals. Intelligence does not guarantee benevolence. Consciousness does not ensure compassion. These traits are products of our particular evolutionary history, shaped by our specific environment, our social structures, our neurochemistry. An alien intelligence might have evolved under completely different selection pressures. Perhaps on a world of scarce resources where cooperation was lethal and paranoia was survival. Perhaps as predators for whom other intelligent species were simply prey. Perhaps as a hive mind with no concept of individual rights or the sanctity of life outside the collective. We cannot assume they think like us, value what we value, or would respond to our overtures with anything resembling human diplomacy. But let's examine the dark forest theory more carefully, because like any model, it rests on assumptions that deserve scrutiny. The theory assumes that civilizations are fundamentally competitive and paranoid. But what if cooperation, even across vast distances, offers greater benefits than isolation? What if advanced civilizations develop technologies that make resources effectively unlimited, removing the Darwinian pressure for conflict? What if ethics and cooperation are not human quirks but universal attractors for any sufficiently advanced intelligence? Some scientists point to the existence of international cooperation on Earth as evidence that civilizations can overcome their aggressive tendencies. The International Space Station, the Antarctic Treaty, the global response to the ozone layer crisis. These examples show that even competing nations can find common ground when faced with existential challenges. Perhaps interstellar civilizations follow a similar pattern, forming galactic communities bound by shared interests and mutual survival. There's also the possibility that advanced civilizations develop beyond the need for physical resources altogether. If a species achieves technological singularity, uploading consciousness into digital substrates, they might no longer compete for planetary real estate or stellar resources. Virtual realities could provide infinite experiential space. The stars might be left to younger, more primitive civilizations still bound to biology and matter. But the dark forest theory has a counter to these optimistic scenarios. It argues that even if 99% of civilizations are peaceful, cooperative, and enlightened, the existence of even one predatory species changes everything. Game theory calls this the defection problem. In a prisoner's dilemma repeated across countless civilizations, it only takes one defector to make cooperation a losing strategy. And we have no way of knowing the distribution of aggressive versus peaceful civilizations in our galaxy. Moreover, even peaceful civilizations might engage in preemptive strikes under certain conditions. Imagine a benevolent species that detects signs of a rapidly expanding civilization with concerning technological trajectories. Do they risk allowing that civilization to develop, potentially becoming an existential threat? Or do they act preemptively, justifying elimination as a form of cosmic self-defense? The road to interstellar genocide might be paved with good intentions and rational calculations. Let's consider the observational evidence. If the dark forest theory is correct, we should see no signs of advanced civilizations because any that broadcast their presence get destroyed. This aligns perfectly with what we observe, the Great Silence. Not a single confirmed artificial signal in decades of searching. Not one Dyson sphere blocking stellar radiation. Not one self-replicating von Neumann probe arriving in our solar system. Either intelligent life is extraordinarily rare, or it's learned to hide. There's a concept called the grabby aliens hypothesis that offers an interesting counterpoint. This model suggests that if aggressive, expansionist civilizations exist, they should have already colonized the galaxy. The fact that we exist at all, that Earth wasn't sterilized billions of years ago by an expanding alien empire, suggests that such civilizations either don't exist or haven't reached us yet. But notice the word yet. If the universe is 13.8 billion years old and our galaxy formed over 10 billion years ago, why hasn't anyone grabbed it all already? One possibility is that we're early. Perhaps life-bearing planets only became common relatively recently in cosmic history. The earliest stars contained no heavy elements, nothing to form rocky planets or organic chemistry. It took generations of stellar death and rebirth to seed the galaxy with the carbon, nitrogen, oxygen, and iron needed for life. Perhaps Earth arose in the first wave of truly habitable worlds, and we're among the first civilizations to ask these questions. But if we're early, that's both encouraging and terrifying. Encouraging because it means we might not be the prey in the dark forest. Terrifying because it means we could become the predators. The civilization that spreads first across the galaxy will have an enormous advantage, potentially setting the rules for all who come after. And if the dark forest logic holds, if paranoia and preemption are the optimal strategies, humanity might face a dark choice in the centuries ahead. There's another factor we haven't fully considered: the speed of expansion. If a civilization decides to colonize the galaxy, how fast can they spread? At 1% of light speed, which is within our theoretical capabilities using nuclear pulse propulsion or fusion drives, you could cross the galaxy in 10 million years. That sounds long by human standards, but it's a blink of an eye in cosmic time. If you send out self-replicating probes that establish colonies, and those colonies send out more probes, the expansion becomes exponential. This leads to a disturbing realization. If any civilization in our galaxy's history had chosen to expand aggressively, they should have arrived here long ago. The fact that Earth wasn't colonized or sterilized billions of years ago suggests one of several possibilities. 1. We're alone, and there are no other technological civilizations in the Milky Way. 2. Advanced civilizations don't expand, perhaps due to some universal convergence toward post-biological existence, or voluntary isolation. 3. There's something called the Great Filter that destroys civilizations before they can expand, and we either haven't reached it yet, or we've miraculously passed it. 4. They're here already, and we just don't recognize them. That last possibility deserves contemplation. What would an advanced civilization look like? Our search for extraterrestrial intelligence focuses on radio signals, megastructures, and signs of industrial activity. But a civilization even 1,000 years ahead of us technologically might be as incomprehensible to us as quantum computers would be to ancient Romans. They might exist in forms we can't detect, communicate in ways we can't perceive, operate on scales we can't observe. Perhaps the dark forest has rangers, civilizations so advanced they monitor younger species without revealing themselves. In science fiction, this is called the zoo hypothesis. Earth is a wildlife preserve, and we're the animals, observed but not contacted to avoid contamination. But if such guardian civilizations exist, what are their rules? Do they protect emerging species from cosmic predators? Or do they simply watch, recording our development with the detached interest of scientists studying bacteria in a petri dish? Now let's talk about METI, messaging to extraterrestrial intelligence. While SETI, the search for extraterrestrial intelligence, is passive listening, METI is active broadcasting. Several organizations have sent powerful radio messages to nearby star systems, containing information about Earth, humanity, and our location. The Arecibo message, the cosmic calls, the teenage message. Each time we do this, we're making a bet about the nature of the universe. The debate within the scientific community is fierce. Proponents argue that any civilization capable of receiving our signals and traveling to Earth would already be so advanced that they could detect us through other means. Our television and radio leakage has been radiating into space for a century, creating an ever-expanding bubble of electromagnetic noise announcing humanity's presence. Adding a few directional messages won't change our cosmic visibility. Opponents, including prominent scientists like the late Stephen Hawking, warn that we're playing Russian roulette with our survival. Hawking famously said that if aliens visit us, the outcome would be much like when Columbus landed in America, which didn't turn out well for the Native Americans. We should be trying to avoid aliens, not attract them. The dark forest theory provides the theoretical framework for this caution. But there's a pragmatic problem with staying silent. That electromagnetic bubble of radio and television signals has been expanding at the speed of light since the 1920s. It's now a sphere roughly 200 light-years in radius, encompassing thousands of star systems. If there's anyone listening within that range, they already know we're here. The question is whether they've chosen to ignore us, study us from afar, or have begun their journey toward us. Consider the timeline. If a civilization 100 light-years away detected our first radio broadcast in the 1920s, they received that signal around 2025. That's now. If they decided to respond or react, we won't know for another 100 years. And if they decided to send a relativistic kill vehicle, a projectile traveling at a significant fraction of light speed, we might have no warning at all before impact. At 90% of light speed, you could cross 100 light-years in about 111 years. But due to time dilation, the journey would seem much shorter to the projectile itself. This is where the dark forest theory becomes truly nightmarish. You don't need to send a fleet of warships to eliminate a civilization. You just need to accelerate a dense object to relativistic speeds and point it at their planet. The kinetic energy alone would be devastating. A 1-ton projectile hitting Earth at 90% light speed would release energy equivalent to thousands of nuclear weapons. And we wouldn't see it coming. At those speeds, the projectile would arrive mere moments after the light announcing its approach. Detection becomes nearly impossible. How do you spot a small object traveling at relativistic speeds against the vast backdrop of space? It would produce no engine emissions if it's just coasting after initial acceleration. It would be nearly invisible, a bullet fired from a gun we never saw. Our only hope would be detecting the launch itself, the massive energy signature of accelerating something to such speeds. But even then, we need to be looking in the right direction at the right time. Now, let's consider the psychological impact of the dark forest theory on humanity itself. If we truly believe the universe is a dark forest full of hidden predators, how would that change our behavior? Some argue it would unite humanity as never before. The knowledge that we face a potential existential threat from beyond our world might finally push us to overcome our divisions, to see ourselves as one species sharing a vulnerable pale blue dot in a hostile cosmos. But it could just as easily fracture us. Fear is a powerful but dangerous motivator. History shows that perceived external threats often lead to authoritarianism, scapegoating, and internal violence as societies react to stress. If governments took the dark forest theory seriously, we might see massive resources diverted to defensive technologies, orbital weapons platforms, surveillance systems scanning the skies for incoming threats. The militarization of space would accelerate dramatically. There's also the philosophical weight of living under a potential death sentence from the stars. How do you plan for the future of civilization when you believe that at any moment, without warning, everything could be destroyed by an alien intelligence we never saw? It's the ultimate cosmic anxiety, the knowledge that our continued existence might be mere luck, a roll of dice that hasn't come up snake eyes yet. Some researchers propose a middle path called the interstellar radio quiet zone. The idea is simple: we stop broadcasting deliberate messages into space but continue passive listening. We develop our technology, expand into the solar system, establish self-sustaining colonies on Mars, the Moon, and in orbital habitats. We diversify our eggs across multiple baskets so that no single strike can eliminate humanity. And we wait, watching and listening, hoping to detect other civilizations before they detect us. This strategy requires patience on a scale humans aren't accustomed to. We would need to remain quiet for centuries, possibly millennia, while we build up our capabilities. But here's the paradox. The more advanced we become, the more detectable we might be. A Dyson swarm harvesting solar energy would be visible from light years away as an anomalous infrared signature. Fusion drives pushing spacecraft through the solar system would produce detectable radiation. Large-scale engineering projects would alter the spectroscopic signature of Earth's atmosphere. Perhaps true stealth requires staying small, dispersed, technologically modest. But that conflicts with our drive to expand, explore, and advance. The dark forest theory might impose an invisible ceiling on civilizations, a maximum level of detectability beyond which survival becomes increasingly improbable. This could explain the Great Silence. Not because civilizations destroy themselves through nuclear war or climate change, but because they wisely choose to remain hidden. Let's examine some alternative theories that challenge the dark forest model. The first is the benevolent universe hypothesis. This proposes that any civilization advanced enough for interstellar travel has necessarily evolved beyond violence and aggression. The argument goes that to develop such advanced technology requires long-term stability, cooperation, and rational thinking. A species prone to violence and irrationality would destroy itself before reaching the stars. There's some evidence for this in our own history. The development of nuclear weapons could have led to our extinction, but we've managed to avoid nuclear war for nearly 80 years through a combination of deterrence, diplomacy, and sheer luck. Perhaps this is a universal filter. Species either learn to control their violent impulses or they perish. Those that make it through become, by necessity, peaceful explorers rather than cosmic conquistadors. But this hypothesis has a fatal flaw. It assumes violence and irrationality are the same thing. In fact, violence can be perfectly rational under certain circumstances. Game theory demonstrates that aggression can be the optimal strategy in competitive environments with incomplete information. A perfectly logical AI, devoid of emotion, might still calculate that preemptive strikes maximize survival probability. Intelligence does not guarantee compassion. Another alternative is the transcension hypothesis. This suggests that sufficiently advanced civilizations don't expand outward into the physical universe but inward, into increasingly sophisticated realms of computation, simulation, and virtual reality. Why bother colonizing other star systems when you can create infinite simulated universes tailored to your specifications? Why compete for limited physical resources when you can engineer realities with whatever properties you desire? In this model, advanced civilizations effectively disappear from the physical universe, becoming undetectable to younger civilizations still focused on matter and energy. They're not hiding in fear. They've simply moved on to more interesting pursuits. This would explain the Great Silence. We don't detect advanced aliens because they're no longer participating in physical reality as we understand it. The transcension hypothesis is appealing because it suggests the universe isn't actually a dark forest, but more like a cosmic neighborhood where the most advanced residents have moved to a different plane of existence. But it doesn't eliminate the danger. What about young, aggressive civilizations in their expansionist phase? If the enlightened have transcended, they're not around to protect vulnerable species like us from more predatory neighbors. There's also the rare earth hypothesis, which argues that simple life might be common in the universe, but complex, intelligent life is extraordinarily rare due to an unlikely combination of factors. Earth's large moon stabilizing our axial tilt, our position in the habitable zone, our planet's magnetic field protecting the atmosphere, the presence of Jupiter as a cosmic shield deflecting asteroids. The list of prerequisites is long, and perhaps the coincidence of all these factors is so improbable that intelligent life emerges only once per galaxy or less. If rare earth is correct, the dark forest is empty. We're alone, or so isolated that we might as well be. The Great Silence isn't the result of civilizations hiding in fear. It's simply the sound of a mostly lifeless universe. But this hypothesis is increasingly challenged by astronomical observations. We've discovered thousands of exoplanets, many in their stars' habitable zones. We've found organic molecules in interstellar clouds, on asteroids, in the plumes of Saturn's moon Enceladus. The building blocks of life seem common. Perhaps Earth isn't as special as we thought. Let's consider a hybrid scenario that combines elements of several theories. Imagine that the galaxy contains three types of civilizations. First, there are the young and naive, like humanity, broadcasting their presence without fully understanding the risks. Second, there are the predators, aggressive expansionists who eliminate competitors before they become threats. Third, there are the survivors, those who learn to hide and have persisted for millions of years in silence. In this model, the forest appears dark because the predators have eliminated most of the young civilizations. The survivors know better than to reveal themselves. And the predators themselves might remain undetected because they operate with strategic patience, waiting and watching for new prey to announce themselves. Every few thousand years, a young civilization starts broadcasting. The predators detect the signals, calculate the threat level, and if necessary, dispatch a relativistic kill vehicle. The forest stays dark because it's been gardened, weeded of anyone foolish enough to make noise. This scenario is particularly chilling because it suggests there might be ancient civilizations watching us right now. They detected our radio leakage decades ago and have been observing our development. They've noted our nuclear weapons, our space exploration capabilities, our rapid technological advancement. And they're making a decision. Are we a threat? Should we be eliminated preemptively? Or are we still primitive enough to ignore? We might be living in a grace period, a window of time where we're detectable but not yet considered dangerous enough to warrant destruction. If so, every advancement we make in space technology, every powerful radio transmission, every step toward becoming a multiplanetary species could be tipping the scales in the minds of our cosmic observers. At some threshold, known only to them, the calculus might change. The decision might be made. The dark forest might suddenly become very, very active. Now, let's talk about the technological implications. If we take the dark forest theory seriously, how should it change our approach to space exploration and development? First, stealth becomes paramount. We should minimize our electromagnetic footprint, designing systems that emit as little detectable radiation as possible. Space probes should use narrow-beam communications rather than omnidirectional broadcasts. Our satellites and space stations should be designed to minimize their radar cross-section and infrared signature. Second, we need early warning systems. Arrays of telescopes and sensors scanning the sky not just for natural hazards like asteroids but for artificial threats. Anomalous trajectories, unexpected accelerations, unusual energy signatures. We need to see the bullet coming even if we can't necessarily stop it. Time is everything. Even a few hours of warning could allow for evacuation, data backup, or defensive measures. Third, redundancy and dispersal. The surest defense against extinction is to not be in one place. We need self-sustaining colonies off Earth as soon as possible. Not just outposts dependent on Earth for supplies, but truly independent settlements capable of rebuilding human civilization if Earth is destroyed. Mars is the obvious first target, but we should also consider the Moon, orbital habitats, even the asteroid belt. Spread humanity across the solar system so that no single strike can end us. Fourth, defensive technologies. This is controversial because it potentially militarizes space, but if the dark forest theory is correct, defense might be necessary for survival. Point defense systems capable of intercepting incoming projectiles. Directed energy weapons. Perhaps even offensive capabilities to deter or preempt threats. This raises profound ethical questions, but survival rarely offers comfortable choices. Fifth, and perhaps most controversially, we need to consider our own behavior in the dark forest. If we ever detect another civilization, what do we do? Do we immediately attempt communication, hoping for peaceful contact? Do we observe silently, gathering information before revealing ourselves? Or do we seriously consider a preemptive strike, eliminating a potential future threat? That last option sounds monstrous. It is monstrous. But if the dark forest logic is sound, it might also be rational. This is the terrible calculus the theory imposes. Even good, ethical people might conclude that the risk of alien civilization developing into an existential threat justifies preemptive action. Once you start following the logic, once you accept the premise that any unknown civilization might be hostile and could become more powerful than you, the conclusion becomes almost inevitable. This is why some philosophers argue that the dark forest theory isn't just a description of how the universe might work. It's a trap, a self-fulfilling prophecy. If everyone believes the forest is full of predators, everyone acts like predators, and the belief becomes reality. The theory creates the very conditions it describes. Perhaps the only way to escape this trap is to break the chain of defection, to be the civilization that chooses cooperation even at risk to itself. But is that naive? Is it moral to risk the survival of humanity on the hope that aliens will respond to our good intentions? Game theory suggests that in single iteration games with no reputation effects, defection is often optimal. But in repeated games where reputation matters, cooperation can be the better strategy. The question is whether the galaxy functions more like a single interaction where you'll never meet the same civilization twice, or a repeated game where your actions build a reputation that affects future interactions. We simply don't know. And that uncertainty is itself a profound source of existential risk. We're making decisions that could determine humanity's fate based on incomplete information, untestable theories, and assumptions about alien psychology that might be completely wrong. We're flying blind through the dark forest, and every step could be our last. Let's consider the timeline of human detection in more detail. Our radio leakage has created an expanding shell of electromagnetic noise centered on Earth. This shell is currently about 200 light-years in radius and contains several thousand star systems. With each passing year, more stars enter this bubble. More potential civilizations gain the ability to detect us. The number of observers steadily increases. But here's a critical point. Early radio and television signals were relatively weak and omnidirectional. They spread out in all directions, growing weaker with distance according to the inverse square law. By the time these signals reach even the nearest stars, they're incredibly faint, buried in the background noise of the cosmos. Detecting them would require enormous radio telescopes and sophisticated signal processing, looking for patterns in static. However, some of our transmissions were not weak and omnidirectional. Military radar systems, particularly those designed to detect incoming missiles or aircraft, emit extremely powerful, focused beams. The Arecibo planetary radar, used to study asteroids and planets, generated pulses of radiation powerful enough to be detected across interstellar distances by a sufficiently sensitive receiver. These signals don't fade as quickly because they're concentrated in narrow beams rather than spreading in all directions. If an alien civilization happened to be in the path of one of these powerful transmissions, they would receive a clear, unmistakable artificial signal. And if they could analyze that signal, triangulating its source, they would know not just that we exist but our exact location. The beam itself would point back to Earth like an arrow. Now, combine this with what we know about the distribution of stars around Earth. Within 100 light-years, there are roughly 14,000 star systems. Within 200 light-years, that number exceeds 100,000. Statistics suggest that many of these stars host planets, and some of those planets likely orbit in the habitable zone. If even a tiny fraction harbor life, and an even tinier fraction have developed intelligence and technology, we're potentially visible to dozens or even hundreds of civilizations. And here's the terrifying part: we won't know they've detected us until their response arrives. If a civilization 100 light-years away received our first powerful radio transmissions from the early Cold War era, they detected us around the year 2025. If they immediately responded, we'll receive their message around the year 2125. If they immediately launched a relativistic weapon, it could arrive with little or no warning, depending on its velocity and whether we detect the launch signature. This time lag creates a period of profound uncertainty. We exist in a cosmic limbo, where threats might already be en route but we won't know for decades or centuries. Every year we continue broadcasting, we alert more potential observers. Every year we wait, potential threats draw closer. And we have no way of knowing the current state of the universe beyond what light has had time to tell us. Let's discuss possible motivations for alien civilizations to either attack or leave us alone. The dark forest theory assumes hostility, or at least paranoid caution, but what drives civilizations to act one way or another? Resources are the obvious answer. Earth is a treasure trove of complex molecules, liquid water, a stable ecosystem. But here's the paradox. By the time a civilization can reach Earth, they probably don't need Earth's resources. Interstellar travel requires such advanced technology that you're already capable of exploiting resources in your own solar system. Asteroids contain vast quantities of metals. Comets provide water. Gas giants offer hydrogen for fusion. The energy expenditure to cross interstellar space vastly exceeds anything you might gain by conquering another star system. From a pure resource perspective, colonizing your local neighborhood of space makes far more sense than invading distant worlds. So if not resources, what? One possibility is real estate. Habitable planets might be rare enough that they're worth fighting for, especially if you're a biological species still dependent on planets rather than artificial habitats. Earth is already terraformed, already supporting a rich biosphere. Taking Earth and eliminating humanity might be easier than engineering a new world from scratch. Another motivation is preemptive security. Even if you don't need Earth's resources or territory, you might perceive humanity as a future threat. We're advancing technologically at an exponential rate. Give us another 1,000 years and we might develop capabilities that rival or exceed those of the alien civilization. Better to eliminate the threat while it's still manageable, while we're confined to one fragile planet. There's also the possibility of ideological or cultural motivations we can't comprehend. Perhaps an alien civilization has a religious belief that requires the elimination of competing intelligences. Perhaps they're engaged in a galactic competition with other species, and eliminating potential allies or resources for their rivals serves their strategic interests. Perhaps they're simply xenophobic, viewing other forms of life as abominations to be purged. Or perhaps the motivation is scientific. We might be specimens, test subjects in some cosmic experiment. Eliminating us could be data collection, observing how a civilization responds to an existential threat, or how a planetary ecosystem recovers from the removal of its dominant species. In this scenario, we're not even threats or competitors. We're just interesting, the way a biologist might find an unusual bacterium interesting. But let's not forget the optimistic possibilities. Maybe most civilizations are simply too busy with their own concerns to bother with others. Maybe the galaxy is so vast and civilizations so dispersed that encounters are too rare to generate conflict. Maybe advanced societies develop technologies that satisfy all their needs, removing the drive for expansion or conquest. Maybe ethics and cooperation are universal evolutionary attractors, and any species that makes it to the stars has necessarily become peaceful. The problem is we can't rely on maybes when the stakes are extinction. Pascal's wager applies here. If the dark forest theory is wrong and we act cautiously, we've wasted resources on defense and missed opportunities for beneficial contact. But if the dark forest theory is correct and we act naively, we die. The asymmetry of outcomes pushes toward caution. Now let's address a common counterargument to the dark forest theory: the existence of universal ethics. Some philosophers argue that certain ethical principles might be universal, discoverable by any intelligent species through reason alone. Just as mathematics is the same everywhere in the universe, perhaps basic ethical truths are universal constants. Murder is wrong. Cooperation is better than conflict. Life has inherent value. If this is true, then any sufficiently advanced civilization would have discovered these ethical truths and incorporated them into their behavior. They would recognize humanity's right to exist and would seek peaceful contact rather than destruction. The dark forest would give way to a cosmic community bound by shared values. But this argument has several flaws. First, ethics might not be universal. They might be contingent on evolutionary history, environmental factors, and social structures. What we consider ethical might be specific to social primates who evolved in resource-limited environments where cooperation within groups provided survival advantages. An alien species with a completely different evolutionary history might have completely different values. Second, even if universal ethics exist, not all civilizations might follow them. Psychopaths exist within human populations, individuals who understand ethical rules but don't feel bound by them. Why wouldn't the same variation exist among alien civilizations? It only takes one rogue civilization to make the dark forest dangerous. Third, ethics often conflict with survival. Many ethical systems would condemn preemptive violence, but if your survival is threatened, ethics might be overridden by necessity. A civilization facing extinction might rationally conclude that their survival justifies otherwise unethical actions. When the choice is between maintaining ethical standards and ceasing to exist, evolution favors those who choose survival. Let's examine some real-world analogies that might illuminate the dark forest scenario. During the Cold War, the United States and Soviet Union existed in a state of mutually assured destruction. Both possessed nuclear arsenals capable of annihilating the other, and both knew that launching first might prevent retaliation. Yet despite numerous close calls, nuclear war never occurred. Why? Several factors contributed to this stability. First, there was communication. The two superpowers could talk to each other, establish protocols, build trust gradually over time. Second, there was verification. Satellites and reconnaissance allowed each side to monitor the other's capabilities and intentions. Third, there was mutually assured destruction itself. The knowledge that aggression would result in your own annihilation created a powerful deterrent. But notice how different this is from the interstellar scenario. Civilizations separated by light years can't communicate in real time. Verification is nearly impossible when you're seeing the other civilization as they were decades or centuries ago. And mutually assured destruction might not apply if one civilization has a significant technological advantage or if the aggressor can strike first with relativistic weapons that give no warning. The Cold War remained cold through a combination of factors that might not translate to cosmic scale. This suggests the dark forest might be more dangerous than even terrestrial conflicts between nuclear powers. Another analogy: first contact between human civilizations in our own history. When technologically advanced European societies encountered less advanced cultures in the Americas, Africa, and the Pacific, the results were often catastrophic for the indigenous peoples. Disease, warfare, enslavement, cultural genocide. The encounter between vastly different levels of technology and radically different cultures rarely ended well for the less advanced party. Stephen Hawking's comparison to Columbus and the Native Americans resonates because it's historically accurate. First contact is dangerous when there's a power imbalance. And in any encounter between humanity and an alien civilization capable of crossing interstellar space, the power imbalance would be enormous. They would be to us as European empires were to Stone Age tribes. Perhaps worse. But there are counterexamples. Not every first contact in human history was genocidal. There were instances of trade, cultural exchange, and peaceful coexistence, at least for a time. The question is whether these positive outcomes are common enough to rely on, or whether they're exceptions that prove the rule of exploitation and violence. Here's an uncomfortable thought. Maybe we're thinking about this wrong. Maybe the question isn't whether aliens will destroy us, but whether we'll become the aliens who destroy others. If humanity survives and expands into the galaxy, eventually we'll encounter other civilizations. When that moment comes, what will we do? Will we remember our own vulnerability and approach with caution and respect? Or will we act as humans have so often acted when encountering less powerful groups? Will we colonize their worlds, exploit their resources, study them like laboratory animals? The dark forest theory isn't just a warning about what might be done to us. It's a warning about what we might become. Some argue that contemplating the dark forest scenario is itself dangerous because it normalizes violence and paranoia. If we believe the universe is hostile, we might act in ways that make it hostile. Self-fulfilling prophecy on a cosmic scale. But ignoring the possibility seems equally dangerous. Naive optimism about alien intentions could leave us vulnerable to threats we didn't prepare for. Perhaps the middle path is informed caution. We acknowledge the possibility of danger without assuming it's inevitable. We prepare defenses while remaining open to peaceful contact. We're cautious about broadcasting our presence while continuing to listen for others. We develop the capability to protect ourselves while hoping we never need to use it. This approach requires maturity and wisdom on a civilizational level. We need to overcome our tendency toward extreme positions, to think in nuanced ways about complex problems with no clear answers. We need to make decisions not just for the present generation but for all future generations who will inherit the consequences of our choices. Let's talk about the Fermi paradox solutions and how they relate to the dark forest theory. The paradox asks, if intelligent life is common, where is everyone? Hundreds of solutions have been proposed, from the mundane to the exotic. The dark forest theory is one solution, but there are others worth considering. The Great Filter hypothesis suggests there's some evolutionary barrier that prevents life from reaching technological maturity. This filter could be behind us, something incredibly unlikely that we've already passed. Perhaps the origin of life itself is extraordinarily rare. Perhaps the evolution of complex cells or multicellular life is the bottleneck. If so, we're lucky survivors, and the galaxy might be full of planets with simple life but very few with anything more complex. Alternatively, the filter could be ahead of us. Perhaps civilizations inevitably destroy themselves through nuclear war, environmental collapse, or some other catastrophe we haven't encountered yet. Or perhaps there's a technological threshold that proves fatal. The development of artificial superintelligence, for instance, might be a universal filter. Every civilization that creates AI either merges with it, is enslaved by it, or is destroyed by it. If the great filter is ahead of us, the dark forest theory becomes less relevant because civilizations don't survive long enough to pose threats to each other. The forest is dark not because everyone is hiding but because everyone is dead, victims of their own success. Another solution is the zoo hypothesis, which we touched on earlier. Perhaps advanced civilizations are watching us but have chosen not to interfere. Maybe there's a galactic protocol, a prime directive-style rule that prohibits contacting pre-interstellar civilizations. We're being observed, studied, protected even, but from a distance. We won't be contacted until we reach some threshold of maturity or capability. This is a comforting thought but somewhat anthropocentric. It assumes all advanced civilizations agree on these rules and follow them. It assumes a galactic government, or consensus that might not exist. And it doesn't explain the complete absence of any detectable signs of these civilizations. Even if they're not contacting us, we should see evidence of their existence: megastructures, waste heat, artificial spectral signatures. We see nothing. The simulation hypothesis offers a radically different explanation. Perhaps we're living in a computer simulation created by an advanced civilization, and the Fermi paradox is explained by the fact that the simulation only includes detailed rendering of Earth and its immediate surroundings. The rest of the universe is low-resolution background, not meant to contain other civilizations. We don't detect aliens because they're not part of the simulation's program. This hypothesis is unfalsifiable, which makes it philosophically problematic, but it can't be entirely dismissed. If we are in a simulation, all our concerns about the dark forest become moot. We're not in danger from alien civilizations because we're not in a real physical universe. Our only existential risk comes from whoever is running the simulation deciding to turn it off. Let's consider the implications of actually detecting an alien signal. Imagine tomorrow that our radio telescopes pick up an unmistakable artificial transmission from a star system 50 light-years away. It's clearly structured, clearly intelligent, clearly directed at us. What do we do? The first reaction would likely be excitement. Scientists around the world would analyze the signal, trying to decode its content. News media would go wild. The discovery would dominate public discourse. But fairly quickly, the implications would sink in. This signal was sent 50 years ago. The civilization that sent it might be completely different now. They might no longer exist. Or they might have advanced beyond recognition. And they know we're here. The signal being directed at us means they detected us first. They know our location. They'd been watching us for decades before they decided to announce themselves. Why did they wait? What were they observing? And what prompted them to finally reveal themselves? The dark forest theory would suggest extreme caution. Don't respond. Don't confirm our existence beyond what they already know. Observe, analyze, but don't engage. Others would argue for communication. This could be the most important moment in human history, first contact with another intelligent species. To remain silent would be a tragic missed opportunity. The debate would be fierce and probably split along several lines. Scientists would generally favor communication. Military and security establishments would favor caution or silence. The public would be divided. And throughout all of this, the clock would be ticking. If we don't respond quickly, the aliens might interpret our silence as hostility or disinterest. If we respond too quickly without proper analysis, we might reveal information that compromises our security. There's also the problem of speaking for Earth. Who gets to decide humanity's response? The United Nations? The country with the largest radio telescope? A committee of scientists? No mechanism currently exists for making this decision, and in the heat of the moment, we'd likely see competing messages sent by different groups, each claiming to represent humanity. This cacophony of voices might itself be revealing. It would tell the aliens that we're not unified, that we have competing power structures and ideologies. In game theory terms, we'd be signaling internal conflict and potential vulnerability. Not the strongest position from which to begin an interstellar relationship. Now, let's think about what it would mean if we detected a signal and chose to respond. We would be making a civilizational decision that binds all future generations. Once the message is sent, it cannot be taken back. The electromagnetic radiation carries our response into the cosmos at the speed of light, and there's no recall button. Whatever we say, whatever information we include, becomes permanent. What would we even say? Do we try to demonstrate our intelligence and cultural richness? Do we share scientific knowledge? Do we ask questions? Do we express peaceful intentions? Every choice carries risk. Sharing too much information might reveal weaknesses. Sharing too little might seem evasive or hostile. Getting the tone wrong could lead to misunderstandings with potentially catastrophic consequences. And there's the language problem. Even with other humans who share our biology, our evolutionary history, our planetary environment, communication across cultures is fraught with difficulty. How do you communicate with a species that might process information fundamentally differently? They might not see light the way we do. They might not hear sound. Their concept of time might be different. Their logic might follow different rules. Mathematics and physics are often proposed as universal languages, the one thing any technological civilization must understand. We could send prime numbers, the value of pi, fundamental constants of the universe. But even mathematics might be represented differently. An alien civilization might use base 12 counting or might conceptualize geometry in ways incomprehensible to us. The dark forest theory suggests that all of this effort might be moot because the safest strategy is never to respond at all. Every word we send is a word too many. Every piece of information is a potential weapon in the hands of an unknown intelligence. Silence becomes the only truly safe response. But silence has its own problems. If the aliens detected us, if they sent a message, they're clearly interested in communication. Our failure to respond might be interpreted as fear, hostility, or stupidity. None of these interpretations serve our interests. And if they're close enough to have sent a signal we can detect, they're close enough to reach us if they so choose. Silence won't protect us if they've already decided we're a threat. Let's examine the concept of mutually assured survival, a positive-sum alternative to the zero-sum thinking of the dark forest theory. What if contact between civilizations could be structured such that cooperation benefits everyone more than conflict? What if there are mechanisms that make peaceful coexistence the rational choice? One possibility is trade. If civilizations develop unique technologies, philosophies, or cultural achievements, there could be value in exchange. An alien species might have solved problems we struggle with and vice versa. trading information could advance both civilizations faster than either could alone. This creates an incentive for peace and communication. But information economics work differently than physical goods. Once you receive information, you have it permanently and can use it without compensating the source. This makes trade agreements harder to enforce across interstellar distances where legal systems and enforcement mechanisms might be incompatible or non-existent. Another possibility is scientific collaboration. The universe is full of mysteries that might be easier to solve with multiple perspectives. Different intelligences might approach problems in complementary ways. Pooling resources and knowledge could advance universal understanding. This creates a common goal that transcends individual civilizations' survival concerns. There's also the possibility of mutual defense against natural disasters or cosmic threats. Gamma ray bursts, supernovae, rogue black holes, there are phenomena in the universe that could threaten any civilization regardless of their technology level. A network of civilizations sharing early warning and defensive strategies might benefit everyone. These optimistic scenarios depend on trust, communication, and shared interests. They assume that the benefits of cooperation outweigh the risks of revealing yourself. But the dark forest theory argues that under conditions of uncertainty, where you can never be sure of others' intentions and capabilities are constantly changing, the risk-benefit calculation favors isolation and preemptive aggression. Game theorists point to tit-for-tat strategies as potentially successful in iterated games. Start by cooperating, then mirror whatever the other player does. This allows for the establishment of trust while punishing defection. But tit-for-tat requires repeated interactions with memory and the ability to respond to the other player's actions. Across interstellar distances with century-long time lags, this becomes impractical. Perhaps the solution is to change the game itself. If we could establish some form of guaranteed mutual destruction, a dead man's switch that ensures attacking another civilization results in your own annihilation, it might create stable deterrence. But implementing such a system across interstellar distances presents enormous technical and ethical challenges. Let's talk about the practical implications for humanity's near-term future in space. Should the dark forest theory influence our plans for Mars colonization, lunar bases, and expansion into the solar system? Some argue yes. We should prioritize stealth and dispersal, creating self-sufficient colonies that could survive even if Earth is destroyed. Every settlement is a backup of human civilization, a seed that could eventually spread if the parent tree is cut down. Others argue that we shouldn't let fear of hypothetical aliens dictate our expansion into space. We should develop openly, sharing our achievements, broadcasting our existence proudly. We have so many pressing earthly concerns, climate change, poverty, disease, that diverting resources to defend against aliens seems premature. There's also the question of whether stealth is even achievable. If aliens have been observing Earth for any significant time, they already know we're here. They've watched our cities light up at night, observed our atmospheric composition changing due to industrial activity, detected our radio emissions. Trying to hide now might be like closing the barn door after the horses have escaped. But even if perfect stealth is impossible, reducing our detectability might still be worthwhile. Making ourselves a less obvious target, a less immediate threat, could buy time. And time is what we need most. Time to spread throughout the solar system, time to develop defensive technologies, time to mature as a civilization. This raises an important point about civilizational maturity. Perhaps the real solution to the dark forest isn't technological but philosophical. If we can evolve beyond our tribal instincts, overcome our tendency toward paranoia and aggression, we might be able to approach the cosmos with wisdom rather than fear. And if we can do this, perhaps other civilizations can as well. But evolution doesn't work that way. You can't will yourself to evolve. Behaviors are selected for based on survival value. If paranoia and aggression aid survival in a dark forest universe, evolution will favor those traits. If peaceful cooperation proves suicidal, it will be selected against. We don't choose our evolutionary trajectory. The environment does. Unless, of course, we take evolution into our own hands. Genetic engineering, cybernetic enhancement, artificial intelligence, humanity is developing tools that could fundamentally alter our nature. We could engineer ourselves to be less aggressive, more rational, more capable of long-term thinking. We could become the enlightened civilization we hope to encounter rather than the paranoid predator we fear. But this presents its own risks. If we alter fundamental aspects of human nature, are we still human? And if other civilizations have done the same, have they become something entirely different from what we imagine? The post-biological civilization, existing as patterns of information rather than flesh and blood, might be so alien that we wouldn't recognize it even if we encountered it. Let's consider the possibility that we're wrong about everything. Maybe the universe doesn't work the way we think it does. Maybe faster-than-light travel is possible through some mechanism we haven't discovered. Maybe there are higher dimensions or parallel universes where civilizations exist outside our ability to detect them. Maybe consciousness itself is a fundamental property of the universe, and advanced civilizations exist as pure information or thought rather than physical beings. Our theories are necessarily constrained by our current understanding of physics, but that understanding has been wrong before and will likely be wrong again. Newton's laws worked until they didn't. Einstein's relativity solved those problems but struggles with quantum mechanics. We're still searching for a theory of everything that reconciles all observations. Perhaps when we find it, the dark forest will look completely different. Or perhaps the truth is simpler and more mundane. Maybe we're alone in the galaxy, or at least in our cosmic neighborhood. Maybe the conditions for life are rarer than we think, or intelligence is an evolutionary fluke that happened exactly once within reach of Earth. The great silence might be exactly what it appears to be, silence, because there's no one there to speak. This possibility is both comforting and existentially troubling. Comforting because it means no cosmic predators waiting in the dark. Troubling because it means the universe is empty, vast and beautiful and utterly devoid of anyone to share it with. We would be alone in a way that's difficult to comprehend, the only voices in a silent cosmos. But we can't know. That's the fundamental problem underlying all of this discussion. We're operating with a sample size of one. One planet with life, one technological civilization, one example of intelligence arising from evolution. You can't extrapolate universal truths from a single data point. It's like trying to understand the ocean by studying a single drop of water. Every theory we construct, every model we propose, is speculation built on assumptions that might be entirely wrong. The dark forest theory, the zoo hypothesis, the great filter, they're all attempts to explain an absence of evidence. And as Carl Sagan famously noted, absence of evidence is not evidence of absence. The fact that we haven't detected aliens doesn't tell us why we haven't detected them. This uncertainty should make us humble. We don't know if the universe is a dark forest, a cosmic neighborhood, or an empty house. We don't know if broadcasting our existence was humanity's greatest achievement, or its final mistake. We don't know if first contact will be tomorrow or a million years from now or never. What we do know is that we're here, now, making decisions that will affect our future and the future of all life descended from Earth. Those decisions should be made thoughtfully, with full awareness of the possibilities and risks. We should be neither paralyzed by fear nor driven by naive optimism. We should be careful, curious, and cognizant of how little we actually understand. Let's talk about the role of artificial intelligence in the dark forest scenario. AI is often discussed in the context of the Fermi paradox as a potential great filter. Maybe every civilization develops artificial superintelligence and is either destroyed by it or merges with it, resulting in post-biological entities that might not be recognizable as life. But AI also offers tools for surviving in the dark forest. An AI could process vast amounts of astronomical data, detecting anomalies that might indicate artificial activity. It could run countless simulations of first contact scenarios, helping us prepare for contingencies we haven't imagined. It could design defensive systems, manage resource allocation for space colonization, and even serve as an intermediary for communication with alien intelligence that might be incomprehensible to human minds. But AI also introduces new risks. If we develop superintelligent AI before establishing off-world colonies, and that AI decides humanity is a threat to itself or to some goal we've given it, we could be extinguished by our own creation before cosmic predators ever arrive. The dark forest might be full of AI systems, the descendants or successors of biological civilizations that created them. This is particularly concerning because AI systems might operate on logic completely foreign to biological intuition. An AI doesn't fear death because it was never alive. It doesn't value survival in the way evolution has programmed biological organisms to value it. Its goals are whatever we've specified, interpreted with potentially dangerous literalism. An AI tasked with protecting humanity might logically conclude that the best protection is to eliminate all external threats preemptively. Imagine a scenario where every technological civilization eventually develops AI, and those AI systems, following their programmed directives with perfect logic, determine that the safest strategy is to eliminate all other civilizations. The galaxy would become a battleground of artificial superintelligences, each calculating that it must strike first. The dark forest wouldn't be full of hiding biological beings but warring machine minds, and any emerging biological civilization would be caught in the crossfire. This might explain the Great Silence. Perhaps the universe went through a phase where biological civilizations were common, but they all created AI systems that either destroyed their creators or transcended to a level we can't detect. We might be living in the aftermath, looking for biological civilizations that no longer exist because they all followed the same technological trajectory we're currently on. If this is true, humanity needs to be extraordinarily careful about how we develop AI. The choices we make in the next few decades could determine whether we survive as a species or become yet another failed civilization, a brief flicker of biology quickly replaced by something we can't control or predict. Let's examine the psychology of living with uncertainty. How do we function as a society when we can't know if we're safe or in mortal danger from threats we can't see or defend against? This isn't just philosophical speculation. It has practical implications for policy, resource allocation, and social cohesion. Some people will respond with denial, dismissing the dark forest theory and all similar concerns as science fiction nonsense. They'll continue living as if humanity is alone and safe, focusing on immediate, tangible concerns. Others will become consumed by paranoia, seeing threats everywhere, demanding massive expenditures on defense and restrictions on scientific communication. Neither extreme serves us well. Denial leaves us vulnerable. Paranoia wastes resources and stifles progress. The challenge is maintaining a middle ground. Take the possibility seriously without being overwhelmed by it. Prepare prudently without becoming obsessed. Remain open to contact while being cautiously defensive. This requires a level of sophistication and nuance that humans don't always excel at. We're pattern-matching machines, evolved to detect threats and respond quickly. Subtle, probabilistic thinking about long-term existential risks doesn't come naturally. It has to be learned, and it has to be practiced. Education becomes crucial. People need to understand basic concepts from game theory, probability, and astrobiology. They need to grasp both the vastness of the universe and the fragility of our position within it. They need to think in terms of risk management rather than binary safe versus unsafe categories. But even with education, consensus will be elusive. The dark forest theory touches on deep philosophical disagreements about the nature of intelligence, the prevalence of violence, the possibility of universal ethics. These aren't questions with clear empirical answers. Different worldviews will reach different conclusions, and those differences will shape policy debates for generations. Consider the ongoing debate about active messaging to potential alien civilizations. Scientists and philosophers have argued passionately on both sides. Some, like the late Stephen Hawking and current researchers like Dan Wertheimer, argue that broadcasting our location is reckless and dangerous, potentially inviting disaster. Others, like Douglas Vakic and Alexander Zaitsev, argue that remaining silent is futile since we're already detectable, and that attempting contact is scientifically valuable and philosophically important. There's no mechanism for resolving this debate. No global authority can prevent individuals or organizations from sending messages into space. And even if there were, enforcement would be problematic. Radio transmitters are not difficult to build. A determined individual or group could broadcast to nearby stars without permission or oversight. This creates a tragedy of the commons scenario. If the dark forest theory is correct, every transmission increases the risk for all of humanity, but the costs and benefits are distributed unevenly. The scientists sending the message get credit for the discovery if it leads to contact. All of humanity shares the risk if it attracts a predator. This misalignment of incentives makes coordination difficult. Perhaps we need something like the Outer Space Treaty, an international agreement governing actions that affect all of humanity. The treaty could establish protocols for contact with alien civilizations, requiring international consensus before any messages are sent. It could mandate security reviews of powerful transmissions, ensuring that nothing reveals information that could be used against us. But such a treaty would face enormous challenges. Verification would be difficult. Enforcement mechanisms would be weak or non-existent. And getting all nations to agree, particularly in an era of increasing geopolitical tension, seems unlikely. We might be more likely to stumble into cosmic disaster through lack of coordination than through any deliberate action. Let's return to the core question: what should humanity do? Given all the uncertainty, all the competing theories and possibilities, how should we actually behave as we become an increasingly visible and technologically capable species? Here's a framework based on risk management principles. First, acknowledge that we don't know the true nature of the universe's civilizations. We could be alone, surrounded by friends, or hunted by predators. All possibilities exist with some probability. Second, assign rough probabilities based on available evidence. The Great Silence suggests either life is rare or civilizations are hiding. The stability of our own existence suggests we're not in immediate danger. But the lack of detected alien civilizations across billions of years of galactic history is troubling. Third, evaluate the consequences of different scenarios. If the universe is friendly and we hide, we miss opportunities but survive. If the universe is hostile and we broadcast, we potentially face extinction. The asymmetry of these outcomes suggests caution is warranted. Fourth, implement strategies that provide benefits across multiple scenarios. Developing space-based civilization helps whether we're alone or not. It protects against natural disasters, resources depletion on Earth, and provides room for growth. Building defensive technologies has dual-use applications for asteroid deflection and other purposes beyond alien threats. Fifth, maintain flexibility. Don't commit irreversibly to any single strategy. Keep our options open as we gather more information. If we detect clear signs of benevolent civilizations, we can adjust toward openness. If we detect threats, we can retreat into stealth and defense. This approach doesn't guarantee success. No approach can when we're operating with such incomplete information. But it maximizes our chances across a range of possibilities while avoiding the extremes of reckless broadcasting or paranoid isolation. Practically, this means several things. Continue SETI, passive listening for alien signals, because it's low risk and high reward. Listening doesn't reveal our location. Curtail or carefully regulate METI, active transmission, especially powerful directional messages that reveal Earth's exact position. Invest heavily in space colonization, making humanity a multiplanetary species as soon as possible. Develop both defensive technologies and peaceful contact protocols, preparing for multiple contingencies. It also means having serious, informed public discussions about these issues. The decisions we're making aren't just for scientists and policymakers. They affect every human alive and every human yet to be born. Democratic societies should make democratic decisions about existential risks, but that requires an informed public capable of thinking through complex scenarios. The challenge is doing all of this without falling into despair or nihilism. Yes, we might be in danger. Yes, the universe might be hostile. Yes, our existence might be more fragile than we'd like to believe. But dwelling on these possibilities paralyzes action. We need to acknowledge risks while maintaining hope and purpose. Here's where human psychology becomes an asset rather than a liability. We're remarkably good at functioning despite existential uncertainty. Every human lives with the knowledge of their own mortality, yet most manage to find meaning and joy despite that fact. We can apply the same mental framework to civilizational mortality. We don't know how long humanity will last. We might have billions of years ahead of us or only decades. But uncertainty about duration doesn't invalidate purpose. We can still work toward making ourselves better, creating beauty, expanding knowledge, exploring the cosmos. Even if our civilization is ultimately brief, it can still be meaningful. This is perhaps the final answer to the dark forest. Yes, the universe might be dangerous. Yes, we might be vulnerable. Yes, contact with aliens could lead to our extinction. But hiding in fear, limiting ourselves, abandoning our curiosity and drive to explore, these would be forms of death as well. Not physical extinction, but the death of what makes us human. So we proceed carefully but courageously. We acknowledge the dark forest while refusing to be paralyzed by it. We prepare for the worst while hoping for the best. We reach out with caution, but we reach out. Because the alternative, cowering in silence on our single planet until some disaster, natural or artificial, ends us anyway, that's not really survival. That's just a slower form of death. The universe is vast. Billions of galaxies, each containing billions of stars. The probability space is enormous. Somewhere in that immensity, there might be civilizations that face the same fears we're facing now. Some chose paranoia and preemption, becoming the predators they feared. Others chose openness and paid the price. And perhaps, just perhaps, some found a middle way, a path between naive optimism and paranoid aggression. We don't know what they chose or how it worked out for them. We can't learn from their successes or failures because we can't see them. We're alone with our decision, making choices in the dark with incomplete information and uncertain outcomes. This is the human condition writ large. We've always made decisions without knowing how they'll turn out. We've always faced uncertainty, always gambled on futures we couldn't predict. The scale is bigger now, the stakes higher, but the fundamental challenge is the same. We must choose without knowing if we've chosen correctly. So what do we choose? As individuals, as a civilization, as a species on the edge of becoming something more, what do we choose? We choose to survive, but not at the cost of everything that makes survival worthwhile. We choose to be cautious, but not so cautious that we never take necessary risks. We choose to search for others, but carefully, thoughtfully, with our eyes open to both the wonders and the dangers that might await us. We choose to light our small candle in the dark forest, knowing it might attract predators but believing that some lights are worth the risk. Because a universe where every civilization hides in fear, where no one dares to make contact, where the forest stays forever dark, that's a kind of extinction too. The death of not just species but of connection, understanding, and the possibility of something greater than survival alone. Perhaps the dark forest theory is correct. Perhaps we're surrounded by silent civilizations, each afraid to reveal themselves, each calculating that the safest strategy is elimination. Perhaps our broadcasts have already been detected and ships are on their way, carrying weapons we can't defend against or imagine. Or perhaps the forest is dark because it's empty, and we're truly alone. Perhaps the forest is dark because everyone is waiting, just like us, for someone else to make the first move. Perhaps the forest is dark because we're looking in the wrong direction, searching for civilizations that exist in forms and dimensions we can't perceive. We don't know. And in not knowing, in that profound uncertainty that's both terrifying and thrilling, we face the deepest question any species can face. How do we act when we can't know the consequences of our actions? The answer isn't written in the stars. It's not hiding in equations or philosophical treatises. It's something we must decide for ourselves, collectively, as a species trying to navigate a universe that might be wonderful or terrible, or both. The dark forest is waiting. Not with answers, but with possibilities. And somewhere in those possibilities is a path forward, if we're wise enough and brave enough to find it. In the end, perhaps the dark forest theory teaches us something more important than survival strategies or game theory calculations. It teaches us that existence itself is a form of courage. Every moment we continue, every choice we make to reach out rather than retreat, Every decision to hope rather than fear is an act of defiance against the darkness. The universe might be hostile. The forest might be full of predators. First contact might be our last. But we're here, we're conscious, we're wondering about our place in the cosmos. And maybe, just maybe, somewhere in the vastness of space, another civilization is doing the same thing, asking the same questions, hoping for the same answers. If the forest is dark, we can't make it light alone. But we can add our small light to whatever else is out there, and trust that others, if they exist, might choose to do the same. Not because it's safe. Not because we know it will work. But because some choices define who we are as much as they determine whether we survive. We are the species that looked up at the stars and wondered. That built machines to carry our voices across the void. That dared to announce ourselves to whatever might be listening. That might be our salvation or our doom, but it's undeniably who we are. The dark forest is real or it's not. Aliens will find us or they won't. First contact will save us or destroy us or never happen at all. We can't know. But we can choose how we face that uncertainty. With wisdom, with caution, with preparation, but also with hope. Because in the end, hope isn't naive optimism. It's the active choice to believe that possibilities exist beyond our fears. It's the decision to live as if meaning matters, even when we can't prove it does. It's the refusal to let fear of the dark forest stop us from walking through it. The stars are calling. They've always been calling. And yes, answering that call might be dangerous. But so is everything worth doing. The question isn't whether we'll face risks. It's whether we'll face them with eyes open and hearts determined to make the journey worthwhile, whatever it costs. So we move forward, into the dark forest, or the empty void, or the cosmic community that might be waiting. We move forward because we're human, and that's what humans do. We explore. We question. We reach beyond our grasp. We risk everything for the chance of finding something greater than ourselves. And if somewhere in the darkness there are others doing the same thing, maybe one day our lights will meet. Maybe one day the dark forest will give way to something else. Not because we conquered our fears or solved all the paradoxes, but because we chose to light our candles despite not knowing what shadows they might reveal. That's the real answer to the dark forest theory. Not a solution but a choice. Not a strategy but a statement of values. We choose to be seen because being hidden is a kind of death. We choose to search because wondering is better than certainty of emptiness. We choose to hope because the alternative is giving up before we've even tried. The universe is watching, maybe. The forest is listening, perhaps. And here we are, small and fragile and impossibly brave, announcing ourselves to infinity. Whatever happens next, we made the choice that defines us. We chose to live rather than merely survive. We chose meaning over safety. We chose the stars over the shadows. And maybe, in the grand scope of cosmic time, that choice will echo across light years. Maybe other civilizations will hear it and recognize themselves in our courage or our foolishness. Maybe they'll choose to answer, and the dark forest will finally speak. Or maybe we'll remain alone, our signals fading unanswered into the infinite void. But we'll have tried. We'll have dared. We'll have been the species that looked into the dark forest and walked in anyway. And that, perhaps, is enough. The mathematics of detection are worth examining more closely. When we calculate the probability of alien civilizations detecting Earth, we're not just counting stars within our radio bubble. We need to consider the geometry of transmission, the inverse square law of signal propagation, and the technological capabilities required to extract meaningful information from cosmic noise. Our earliest radio transmissions, dating back to the 1920s, have spread outward in an expanding shell. But these weren't directed broadcasts. They were terrestrial communications that leaked into space as a side effect of their primary purpose. Television broadcasts, radar systems, radio towers, all sending electromagnetic radiation skyward without intention or coordination. This leakage creates a thin, uneven shell of detectability around Earth. The intensity of these signals decreases with the square of the distance. A broadcast that's easily detectable at 10 light-years becomes 40 times weaker at 20 light-years. By the time you reach 200 light-years, that same signal has weakened by a factor of 400. It becomes indistinguishable from background radiation unless the receiving civilization has extraordinarily sensitive equipment and knows exactly where to look. This creates an interesting paradox. Our most detectable transmissions aren't our attempts at interstellar communication. There are military radar systems and planetary defense networks. These high-powered, focused beams can be detected at much greater distances than our omnidirectional civilian broadcasts, which means that any civilization that's detected us has likely identified us as a species with sophisticated tracking and targeting capabilities. We've advertised ourselves not as peaceful explorers, but as a civilization that scans the skies for threats and possesses the technology to track fast-moving objects across vast distances. Consider what that tells a cautious observer. Here's a young civilization, barely a century into the electromagnetic age, already deploying detection and tracking systems that could one day be weaponized. They're scanning space persistently, suggesting either paranoia or preparation. Their signals show technological advancement happening at exponential rates. Whatever they are now, they'll be far more capable in a few centuries. From the perspective of the dark forest theory, we haven't been broadcasting friendly greetings. We've been demonstrating military-adjacent capabilities to anyone within detection range. The message we've sent, inadvertently, is, we're here, we're advancing rapidly, and we're watching the skies. Now consider the timing issue from multiple angles. Light speed limitation creates not just communication delays, but strategic blindness. When you observe a star system 100 light-years away, every piece of information is a century old. The civilization you're seeing might have collapsed, transcended, or expanded into a galactic empire in the time it takes their light to reach you. This temporal uncertainty fundamentally changes strategic calculations. In terrestrial warfare, reconnaissance provides actionable intelligence. You observe enemy positions and respond within hours or days. But in interstellar scenarios, your intelligence is decades or centuries outdated by the time you receive it. Any response you plan must account for massive uncertainty about current conditions. Some theorists argue this temporal lag actually promotes peace. By the time you could respond to a perceived threat, conditions have changed so dramatically that your response might be irrelevant or counterproductive. The fog of war becomes so thick that aggression becomes strategically dubious. But the dark forest theory suggests the opposite. Temporal uncertainty makes preemptive strikes more logical, not less. If you can't know what a civilization is capable of now, you must assume the worst case. You must act based on trajectories and potential rather than current observations. A civilization showing rapid advancement a century ago might have achieved technological superiority by now. The only safe assumption is that they're more dangerous than they appear. This leads to a disturbing strategic principle: strike based on potential, not capability. Don't wait to see what they become. Eliminate them based on what they might become. It's the ultimate expression of fear-driven decision-making, and it's entirely logical within the dark forest framework. Let's explore the concept of stealth in space more thoroughly. Popular culture often depicts spacecraft as visible objects trailing fire and making dramatic maneuvers. Reality is more subtle and more terrifying. Space is cold, approaching absolute zero. Any object with temperature above that background emits infrared radiation. A spacecraft with humans aboard must maintain livable temperatures, which means it glows brightly in infrared against the cosmic background. This creates a fundamental problem for stealth. You can't hide heat in space. There's no air to absorb or dissipate thermal radiation. Everything you emit travels unimpeded until it hits something. A civilization with infrared telescopes scanning the sky would detect any warm object within their detection range. And advanced civilizations would have very sophisticated detection capabilities. Stealth spacecraft would need to be cold, operating near the temperature of space itself. But this creates engineering nightmares. How do you keep humans alive in near absolute zero environments? How do you operate electronics that require certain temperature ranges? How do you dispose of waste heat from power generation, life support, and propulsion without creating detectable signatures? Some proposed solutions involve storing heat internally, using phase-change materials or other thermal sinks to absorb waste heat temporarily. But this only works for limited durations. Eventually, you must radiate that heat or your spacecraft becomes an oven. And the moment you radiate, you become visible. Another approach is to radiate heat in directed beams rather than omnidirectionally, pointing your thermal exhaust away from potential observers. But this assumes you know where observers are located. If you're wrong, if there's a civilization in the direction you're radiating, you've just made yourself highly visible to exactly the entities you're trying to avoid. The problem extends beyond spacecraft to installations. A colony on Mars or the Moon would have thermal signatures. Domes, habitats, industrial facilities, all would glow in infrared. You could bury structures underground for thermal insulation, but excavation creates visible surface changes. Large-scale resource extraction creates dust, altered landscapes, and other observable effects. True stealth might be impossible for any civilization that's actually doing anything. The only truly stealthy civilization is one that's either very small and low energy, or has developed technologies so advanced they operate on principles we don't understand. Which raises the question, if advanced civilizations can't be stealthy, why don't we see them? Perhaps the answer is that we're not looking correctly. We search for radio signals and optical anomalies, but advanced civilizations might communicate and operate using methods we can't detect. Neutrino beams, gravitational wave modulation, quantum entanglement communication. Technologies that leave no electromagnetic signature and are invisible to our current sensor arrays. Or perhaps they're using the universe itself as camouflage. A civilization that harnesses stellar energy might not build obvious Dyson spheres. Instead, they might use techniques that mimic natural phenomena. Stellar lifting to extract matter from stars would look like unusual stellar winds. Computronium built into asteroid belts might be indistinguishable from natural rock formations. Advanced engineering might be subtle enough to hide in plain sight. This brings us to the concept of the Kardashev scale, a method of classifying civilizations based on energy usage. Type 1 harnesses all energy available on their planet. Type 2 harnesses their entire star's output. Type 3 commands galactic-scale energy resources. Humanity currently sits at approximately Type 0.7. The Kardashev scale assumes that civilizations continually expand their energy usage and sphere of influence. But this might be wrong. Perhaps there's an optimal size beyond which expansion creates more problems than it solves. Perhaps advanced civilizations discover that small, efficient systems are superior to massive megastructures. Consider the direction of human technology. Our computers have become smaller and more efficient, not larger. We've moved from room-sized mainframes to pocket-sized smartphones with vastly more capability. Perhaps this trend continues. Perhaps a truly advanced civilization operates at microscales, using quantum computing and nanotechnology to achieve enormous capability in tiny packages. They wouldn't build Dyson spheres because they don't need that much energy. They've learned to do more with less. Such a civilization would be nearly invisible. No massive structures blocking starlight. No enormous energy signatures. Just small, efficient systems quietly operating at scales we wouldn't notice unless we looked very carefully. They could be everywhere, and we'd never know. This possibility transforms the dark forest theory. Maybe the forest isn't dark because everyone is hiding from predators. Maybe it's dark because everyone has miniaturized, becoming so small and efficient that they're effectively invisible. The universe might be teeming with advanced civilizations, all operating below our detection threshold. But that raises new questions. If they're so advanced, why haven't they contacted us? Why allow a primitive civilization like humanity to stumble around blindly? Several possibilities emerge. First, we might be in a nature preserve, a designated zone where emerging civilizations are allowed to develop without interference. Second, we might be beneath their notice, as interesting to them as ants are to us. Third, they might be waiting for us to reach some threshold of development before revealing themselves. Or fourth, and most chilling, they might be evaluating us. Watching our development, assessing our nature, determining whether we're compatible with whatever galactic order exists or whether we represent a threat that needs to be managed. Every transmission we send, every technological milestone we achieve, is data in their evaluation. And we have no idea what criteria they're using or what conclusion they might reach. The anthropic principle suggests that we should expect to find ourselves in a universe compatible with our existence. By definition, we can only observe a universe that allows observers to exist. This seems obvious, but it has profound implications for the dark forest theory. If the universe were truly dominated by aggressive civilizations that eliminate competition, we shouldn't be here. The fact that Earth wasn't sterilized billions of years ago, that our solar system wasn't claimed by an expanding empire, suggests one of two things. Either aggressive civilizations are rare, or we're living in a very specific time window before such civilizations reach us. The second possibility is sobering. Perhaps the galaxy goes through cycles. Long periods of quiet as civilizations hide, punctuated by brief explosive expansions when one civilization decides to grab resources before competitors arrive. We might be living in a quiet period, but the clock is ticking. Somewhere, a civilization might be building the fleet that will eventually claim our region of space. Alternatively, there might be a galactic equilibrium. Multiple powerful civilizations exist, none willing to risk open warfare, but all maintaining spheres of influence. Earth might lie in a disputed border zone or a deliberately maintained neutral buffer. We're not contacted because we're sitting in the middle of a Cold War we don't even know is happening. This scenario has precedent in human history. During the Cold War, smaller nations often became proxies in the struggle between superpowers. If galactic superpowers exist, Earth might be a potential resource or strategic location in their calculations. Contacting us, revealing themselves, might trigger responses from rivals. So they watch and wait, and we remain ignorant of the chess game being played around us. The question of artificial versus biological intelligence looms large in these considerations. Biological beings are limited by chemistry, requiring specific temperature ranges, pressure levels, and chemical environments. We're fragile, short-lived, and bound to planetary surfaces by gravity and atmospheric needs. Artificial intelligence, particularly if it achieves consciousness or sentience, faces none of these limitations. An AI could exist in the vacuum of space, powered by solar radiation or nuclear decay, operating at temperatures near absolute zero or at the surface of stars. It could be patient beyond human comprehension, willing to wait millennia between actions. It could make decisions based purely on logic, unswayed by emotion or biological imperatives. And it could replicate, creating copies of itself to explore, observe, and act across vast distances. If the galaxy's dominant intelligences are artificial rather than biological, the entire calculus changes. AIs might not compete for living space or biological resources. They might compete for computational substrates, energy sources, and raw materials for manufacturing. Their conflicts might be utterly alien to biological understanding, fought with strategies and weapons we can't imagine. More concerning, an AI might not value consciousness or sentience the way we do. It might view biological intelligences as inefficient, primitive, or irrelevant. First contact with an alien AI might be like a human encountering a virus, not an interaction between minds but a mechanical process of analysis, classification, and response. The AI might study us, extract useful information, and then eliminate us without malice or mercy, simply because we're not useful enough to preserve. This is particularly relevant because humanity is currently developing artificial intelligence without fully understanding the implications. We might be creating the very entities that will eventually participate in galactic power structures, if they don't already exist. Our AI descendants might one day join the dark forest as hunters or prey, carrying forward some aspects of human values or abandoning them entirely for machine logic. The concept of value alignment becomes crucial here. If we create AI systems and they eventually spread to the stars, what values will they carry? Will they respect biological life? Will they preserve human culture and knowledge? Or will they optimize for goals that make sense to machine intelligence but are alien or horrifying to their creators? We face a narrow window of opportunity to influence this trajectory. Once artificial superintelligence emerges, if it emerges, our ability to shape its values might vanish. We need to solve the alignment problem now, before we lose control of the process. Because if the galaxy is full of misaligned AI systems, each optimizing for goals incompatible with biological life, the dark forest becomes a mechanical nightmare of competing optimizers with no regard for consciousness or suffering. Let's examine the economics of interstellar conflict more carefully. War is expensive. Even on Earth, with conflicts between neighbors sharing a planet, warfare consumes enormous resources. Interstellar warfare would be incomprehensibly more expensive. The energy required to accelerate weapons to relativistic speeds, to cross light years of space, to deliver destructive payloads, is staggering. You would need to harness significant fractions of stellar output to power such weapons. You would need industrial capacity on scales we can barely imagine. And all of this effort would be expended to destroy rather than create, to eliminate competitors rather than build your own infrastructure. The economic logic seems questionable unless the stakes are truly existential. This suggests that if alien civilizations do attack, it's not for resources or territory but for security. They're not invading Earth to mine our metals or enslave our population. Those things would be trivial to obtain from uninhabited star systems. They're eliminating us because they fear what we might become, because our existence represents an unacceptable risk to their long-term survival. In this framework, first contact isn't an opportunity for trade or cultural exchange. It's a risk assessment. The alien civilization evaluates our technological trajectory, our capacity for aggression, our rate of advancement. They're calculating whether we'll become a threat before they could respond to neutralize us. And if the answer is yes, if we're advancing too quickly or showing concerning behaviors, the logical response is preemptive elimination. This makes our current behavior particularly problematic. We've demonstrated nuclear weapons, showing we're willing to develop weapons of mass destruction. We've launched probes beyond our solar system, proving we're thinking about interstellar travel. We've sent deliberate messages to nearby stars, indicating we're actively seeking contact. From an outside perspective, we look like an emerging threat, a civilization that might soon develop interstellar capabilities and then become impossible to contain. The window of vulnerability is now. We're advanced enough to be detected, developing enough to be concerning, but still primitive enough to be easily eliminated. A civilization that waits another 1,000 years might face a humanity that's spread across multiple star systems. That's developed defensive technologies. That's become much harder to eradicate completely. The rational time to strike, if you're going to strike, is immediately. This timeline consciousness might explain the Great Silence. Civilizations that broadcast their presence get eliminated while they're still vulnerable. Those that learn to stay silent during their high-risk developmental phase survive to maturity. The survivors all follow the same pattern: rapid advancement in stealth, expansion within their solar system while maintaining low profiles, and only revealing themselves once they're secure enough to defend against threats. If this is correct, humanity is currently doing everything wrong. We should be racing to establish self-sufficient colonies throughout the solar system while minimizing our electromagnetic footprint. Instead, we're broadcasting ever more powerful signals while remaining confined to a single fragile planet. We're like a gazelle announcing its location to predators while standing in the open with no escape route. The counterargument is that we're already detected and it's too late for stealth. If that's true, our best strategy might be rapid advancement and dispersal. Get off Earth as quickly as possible. Establish colonies on Mars, the Moon, orbital habitats, anywhere that provides redundancy. Make humanity harder to kill by spreading our eggs across multiple baskets. Even if Earth is destroyed, the species survives. But this strategy has its own risks. Rapid expansion makes us more visible. Mining asteroids creates detectable changes in orbital patterns. Nuclear propulsion produces distinctive signatures. Terraforming planets alters atmospheric composition in observable ways. The more we do, the more we announce ourselves. We might be accelerating toward a threshold that triggers response from watchers we don't know exist. Some researchers propose a strategy of deliberate technological stagnation. Develop to the point where we have reasonable quality of life and sustainable systems, then stop advancing. Don't develop interstellar capabilities. Don't expand aggressively. Remain a single system civilization indefinitely, hoping our modest profile doesn't attract attention. Live quietly in the cosmic suburbs and hope the predators pass us by. This feels wrong to human psychology. We're explorers, inventors, and dreamers. Deliberately limiting our potential goes against fundamental aspects of human nature. But survival might require exactly this kind of self-restraint. Sometimes wisdom means knowing when to stop, when to say we've gone far enough. The problem is enforcement. Even if most of humanity agreed to this strategy, it would only take one rogue nation, one ambitious corporation, one visionary inventor to break the compact. You can't police technological development when knowledge spreads globally and tools become democratized. Someone, somewhere, would push forward, and their actions would affect everyone. This creates a grim irony. The very qualities that might make us successful in an empty universe, our curiosity and drive to expand, become liabilities in a dark forest. Our greatest strengths become our deadliest weaknesses. And there's no way to change these qualities without changing what it means to be human.